So this is problem 16 of the MIT integration B-qualifying exam 2017, which is the definite integral from x tending negative infinity to x tending to positive infinity of sine squared of x plus pi over 4 over e to the power x squared. So the problem looks kind of intimidating, but it's actually doable. It's solvable. So let's see how we may be able to solve this. So this is our problem, right? The important thing here is to know that your Gaussian integral. Integral from x tend negative infinity to x tend to positive infinity of e to the minus x squared is equals to square root of pi. So if you know this, then this problem is easy to solve. So our problem is the same as sine squared x over 4 times e to the minus x squared integrated from x tending to negative infinity to x tending to positive infinity. One thing to note is that this can be separated into two separate integrals. The negative domain to the positive domain and the positive domain, right? So we've separated our problems into two separate integrals. Now let me just rewrite this so that it's clear. Now, the other thing that is worth noting is that we can make everything negative on the x side if we let u be equal to negative x or vice versa. That means dx is equals to negative du. And then what that means is that we have positive infinity 0 sine squared negative u plus pi over 4 e u squared negative du plus 0, and we keep the second one, we'll just keep x as it is, like that. And then this negative here allows us to flip the signs, the limits. Okay, so we have our problem. We could actually even convert this back to x so that we have a problem that is sine squared negative x plus pi over 4 plus sine squared x plus pi over 4 ex squared. So that is what our problem has become. It's important to know that sine x plus pi over 4 is equals to sine x cosine pi over 4 plus sine pi over 4 cosine x, which is equals to sine x 1 over root 2 plus 1 over root 2 cosine x, which is the same as, we can pull 1 over root 2 out, sine x plus cosine x, meaning that sine squared x plus pi over 4 is the same as 1 over root 2 squared sine x plus cosine x squared, which is a half sine squared x plus cosine squared x plus 2 sine x cosine x, right? Now, however, sine negative x plus pi over 4 is equals to sine of negative x cosine of pi over 4 plus sine pi over 4 cosine of negative x. Cosine of negative x is the same as cosine x, but sine of negative x is the same as negative sine x. So which is the same as 1 over root 2 cosine x minus sine x. Therefore, sine squared negative x plus pi over 4 is the same as 1 over root 2 cosine squared x plus sine squared x minus 2 sine x cosine x. So our integral, that is from 0 to infinity, x tends to infinity, of sine squared negative x plus pi over 4 plus sine squared x plus pi over 4 e negative x dx is the same as, this part here is 1, so this is the same as 0 to infinity, a half cosine squared x plus sine squared x minus 2 sine x cosine x corresponding to this part, plus a half cosine squared x plus sine squared x plus 2 sine x cosine x cross bracket e squared x. Now as you can see, this part is 1, this part is 1, but this part and this part cancel out, right? So our problem now becomes integral from x equals 0 to infinity of a half plus a half e squared x, which is 0 to infinity of e, which is the same as a half integral from negative infinity to infinity of ex squared, which is a half of the root of pi. So our integral negative infinity plus infinity sine squared x pi over 4 over ex squared equals to a half square root of pi, and that is our answer. So until next time, bye bye. Hope you did enjoy following along.